Hello, and welcome to our experiment, the bendulum. The goal of our experiment is to measure the damping coefficients of different shaped pendulums to best approximate the bendulum. To do this, we've made 3 pendulums with different shaped die, as well as the bendulum. We then use the linear pendulum mass damper equation to calculate the damping coefficient C. Our experiment relates to dynamics because we use the damped free vibration equations, and also relates to math because we are using MATLAB to then graph the approximation of the path using our calculated damping coefficient.
Hey Nathan, how about you approximate this pendulum?
Ah, Spencer, good one. You're so very smart, funny, and attractive, and a Costco executive member. Wait, who wrote the script?
Alright Nathan, stop schlunking it.
Anyways, we first connected each die to the fishing line, then weighed their combined mass and recorded their oscillations while holding the line in riser.
Then for the pendulum, we basically did the same thing, but with a harness and climbing rope tied around a parking lot structural beam.
In order to reduce drag, we then had to cover Ben in 60 million gallons of baby oil.
From the recordings, we were then able to use the tracker open physics software to get position and time data.
With these values, they can use MATLAB, solve it for me, Ben. But an analytical solution to the ordinary differential equation compared to the actual displacement time graphic on the tracking software. We then plotted the data from the tracking software and calculated the damping coefficients for each object by finding the logarithmic decrement with the exponential slope of best fits. We then got these values. Then, we graphed the ODZ using the calculated damping coefficients for position versus time and plotted beside the original position versus time graph from the tracking software.
Our results show that a linear approximation of drag for small lightweight pendulums is sufficiently accurate in magnitude, however not in gauge. This could be because of our linear approximation of drag and constant damping coefficient C, resulting in the amount of damping being correct, but the frequency being wrong. Limitations include.
But I don't understand why the
Limitations.
would be of interest to anybody. It's pretty boring stuff. It's
The tracker software accuracy, possible changes in airflow or wind, error in rope length measurements, and our approximation of the damping coefficient did not consider all peaks. The pendulum was most closely approximated by the V20 because of its many jagged edges. However, there may have been some experimental error in approximating Ben as a point mass, stretching of the rope, rotation on top of points mentioned on top.
Therefore, we can assume our error is plus minus Ben.
Is that a banana in your pants? Or you just happen to see